Hey, geometry students. First of all, sorry that I can't be there today. Dolly had a bit of an emergency last night, so you'll have to do your best to work with each other and learn this together. So here goes. In this lesson, we're going to talk about finding the circumference of a circle and then finding the arc length based on that circumference. Okay, so if you remember, you should have already talked about how to find what the circumference is in previous math classes. So the circumference of a circle is just talking about the distance all the way around the circle. And that formula is 2 pi r. Pi, today is actually pi day. So pi is just the number 3.14. So this is like saying 2 times 3.14 times the radius r. So in this example, if we were to find the circumference, we would do 2 times pi times our radius, which is 16. And then I like to leave my answers in terms of pi, and I'm going to have you guys leave your answers in terms of pi for the arc length as well. So I would answer this as 32 pi. The SAT likes to leave answers in terms of pi. Also, they won't have you convert that to decimal form. So we're just going to go ahead and leave the pi in our answer. Again, pi is just a number. So if we wanted to convert that to decimal form, that would be us doing 32 times roughly 3.14. I'll show you what that looks like on a calculator. It's 32 times pi. So it's about 100.53 units. And in this case, our units were inches, so it's about 100.53 inches. And again, that's talking about the length all the way around the edge of the circle. Okay, in the second example, if we're going to find the circumference, what I notice is that in this problem, they don't give us the radius, they give us the full length of the diameter. So we should know that that diameter gets split into 2 equal pieces, and those 2 equal pieces are the radius. So if the diameter is 22, the radius, or that yellow length, would be 11, and the green length would be 11. So in this problem, our radius is 11. So if we're going to find the circumference, we're going to do 2 times pi times 11, which is roughly, well, not roughly, it is 22 pi. And I like answers left like that, so go ahead and just leave it as 22 pi. And in this case, it's 22 pi meters. Now, the arc length is going to build off of that. So the arc length is us measuring a certain length of an arc, of some intercepted arc. So if I look at this example here, okay, I've got this 80-degree angle is intercepting this arc. Now, that, if I want to find that length exactly, it's going to be a proportion out of the whole. So what I'm going to do for arc length is I'm going to actually take that circumference and I'm going to multiply it by the proportion. So the proportion of the whole. So mathematically, what that's going to look like is us doing 2 pi r multiplied by our angle out of 360. So in this problem, if I do it with this example, my arc length, so the length of this yellow piece, we're going to label that as S. A lot of times we like to use S as our arc length. Okay, so our arc length, S, is equal to 2 times pi times 6 times 80 divided by 360. So that 80 over 360 is the proportion of the whole. This part is my circumference. This part is the proportion of the whole. All right, now I'm going to clean this up a little bit. So I know that I have 12 pi multiplied by an 8 over 360, both 8. So the zeros can divide out, the 8 and 36. Both are going to divide by 4, so I'm getting 2 over 9 for this. And then I'm going to simplify a little bit further for my arc length. And the 12 and the 9 can also both divide by 3. So this is going to become a 4 and that's going to become a 3. So my final answer I'll leave as 8 pi over 3. So my arc length, this yellow length right here, is 8 pi over 3 centimeters. It's always important that we use our units in our final answer. Now, some of you might have noticed in this problem that we have part of this formula can be simplified from the start. So some of you might have seen that we have this 2 in the numerator and this 360 in the denominator can both divide by 2. Okay, so if you don't like thinking of this as circumference times the proportion and you want to do the fully simplified version, you could also think of this formula as pi times the radius times your angle over 180. The reason you can do that is because the 2 and 360 can both divide by 2 and simplify out. So I'm going to go ahead and approach problem number 1 here in both ways. So I'm going to find the arc length. Now in this example, I want the arc length of, it looks like this is not drawn out very well, but I want this arc length from G to F. All right, so what I'm going to do is I want to do, oops, that really just moved over on us, huh? Whoopsies. Okay, so I want the arc length from G to F. So I'm going to do the circumference. So our arc length is equal to the circumference times the proportion of the whole, so 134 out of 360. All right, and the circumference is 2 pi times 8. So this is 2 pi times 8 times 134 out of 360. Now, if you have a calculator, you can type all this in and make it a lot easier and then hit math, enter, enter. I'm going to go ahead and do all my crazy simplifying here. I know that 2 and 360 will divide, so this is my 180 that I talked about earlier. 8 and 180 also divide by 2. So this will be 4 and then 90. And then this divides by 2 again, so that's a 2, and this is 45. And then I think from there I should be done simplifying. I don't think 2 and 45 won't divide by anything in common, and 134 and 45, I don't see anything there. So then I'm going to multiply. This is 2 times pi times 134 all over 45, which is 268 pi over 45. And that is in centimeters. Okay, for the last example, before I let you guys work on your own, what I'm going to do is I'm going to do this one using the shortened version. So I'm going to use this version of the same formula where I just divide out the 2 and 360 from the start. Okay, so the arc length is equal to pi times the radius times your angle over 180. So in this case, I'm going to do pi times a radius of 2 times our angle, which is 62, over 180. When I simplify that, I am dividing, 2 can divide out. That's 90. Again, you can do this on your calculator. 62 and 90 both also divide by 2. So in the top I have 31 and in the bottom I have 45. And then that's as far as I'll get. So it's 31 pi over 45 meters, it looks like. Okay, that's it for finding arc length. Go ahead and try your MyOpen math for practice.